Have you ever wondered what happened to the atmosphere of Mars? Why is it so different from Earth's? This question has captivated the minds of scientists and space enthusiasts alike for decades. The fourth planet from the Sun, Mars, presents a fascinating mystery. Once upon a time, this distant red world boasted an atmosphere thick enough to hold liquid water on its surface. Imagine a Mars that was possibly warm, wet, and teeming with the potential for life, much like our own home planet. But today, Mars stands as a stark contrast to this ancient image, with an atmosphere so thin and cold that water can only exist as ice or vapor. What led to this dramatic transformation? What cataclysmic event or slow process stripped Mars of its once Earth-like atmosphere? These are questions that scientists have been trying to answer. Today, we will embark on a journey to unravel the mystery of what really happened to Mars's atmosphere. Our journey begins billions of years ago when Mars was a young planet. Picture a world not dissimilar to early Earth, where the air was thick and the climate was warmer and wetter than it is now. Mars, in its infancy, was a vibrant world teeming with potential for life. This early Mars was a far cry from the red, barren desert we're familiar with today. Scientists believe that the planet once boasted a thick atmosphere, rich in carbon dioxide. This atmosphere, much denser than the one Mars has now, would have trapped the sun's heat, creating a greenhouse effect and warming the planet's surface. Mars's temperate climate would have allowed for the presence of liquid water, a vital ingredient for life as we know it. Evidence of this can be found in the form of ancient river valleys, carved into the Martian surface. These riverbeds suggest that water once flowed freely on Mars, nourishing its landscapes. But it wasn't just rivers that graced this early Martian terrain. Scientists have also found signs of ancient lakes, their basins now dry, but their past existence etched into the Martian soil. These lakes may have once teemed with microbial life, their waters a cradle for the planet's potential inhabitants. And then there's the possibility of an ocean. Some researchers argue that Mars may have once had an ocean that covered a third of its surface. Imagine a Martian ocean, its waves lapping against the shore under a pink sky, its depths possibly teeming with life. The very thought is enough to send shivers down the spine. But this vision of Mars, of a warm, wet world, is a far cry from the cold, dry planet we know today. The rivers have long since dried up, the lakes have vanished, and the ocean, if it ever existed, is no more. The thick atmosphere that once blanketed the planet has been stripped away, leaving behind a thin, weak shell. However, this Mars is vastly different from the Mars we know today. What happened? As we delve deeper into the mystery of Mars, we'll attempt to answer that question, piecing together the story of a planet that once held the promise of life, but now stands as a testament to change and loss. Fast forward to 1 billion years later, Mars began to change drastically. Picture this, a thriving, warm planet with a thick atmosphere, suddenly beginning to lose its life-sustaining shield. That's what happened to Mars around 4 billion years ago. But why? Let's dive into the theories that attempt to answer this question. The first theory points to the solar wind, a stream of charged particles continually flowing from the sun. Now, Earth's magnetic field protects us from this solar onslaught, but Mars wasn't so lucky. You see, Mars once had a magnetic field, but it weakened and eventually disappeared. We believe this happened because the planet's core, made of molten iron, began to cool and solidify. And without a magnetic field, the solar wind had a direct ticket to the Martian atmosphere. The solar wind didn't just blow past Mars, it interacted with the atmosphere. These charged particles collided with the atmospheric molecules, giving them enough energy to escape Mars's gravitational pull. Over billions of years, this process, known as atmospheric stripping, caused the Martian atmosphere to slowly but surely vanish. But solar wind isn't the only suspect here. Some scientists believe that Mars's volcanoes played a role too. In the early days, these volcanoes spewed out gases, contributing to a denser atmosphere. But as the planet's internal heat engine slowed down, the volcanic activity decreased. This meant fewer gases were being added to the atmosphere, which could have also contributed to its thinning. Now, it's important to note that these theories aren't mutually exclusive. It's likely that a combination of these factors caused Mars's atmosphere to dwindle, and while the process was gradual, its effects were profound, transforming Mars from a potentially habitable world into the barren, cold desert we see today. But how do we know all of this? What evidence do we have? Science, as always, requires evidence, and in the case of Mars, we have quite a bit. Let's delve into the fascinating world of cosmic detection to understand the various pieces of evidence that support the thinning atmosphere theory. Over the years, space missions, rovers, and satellites have been instrumental in collecting this evidence. One of the primary pieces of evidence comes from the Mars Atmosphere and Volatile Evolution, or MAVEN, mission. Launched by NASA in 2013, MAVEN has been studying the Martian upper atmosphere, ionosphere, and interactions with the sun and solar wind. It has provided clear evidence of how the solar wind strips away gases in the Martian atmosphere, causing it to thin over time. Then we have the Mars Express Orbiter, a mission by the European Space Agency. This satellite has been in orbit since 2003, and it has detected an abundance of deuterium in the Martian atmosphere. Now, deuterium is a form of hydrogen that doesn't escape the atmosphere as easily. A high concentration of deuterium is a clear sign that lighter hydrogen has escaped, leading to the thinning of the atmosphere. Next we have the Curiosity rover, our trusty Martian geologist. Curiosity has been analyzing rocks and soil on Mars, and it has discovered that they contain isotopes, forms of elements, that are usually found in a thick atmosphere. This is a clear indication that Mars once had a denser atmosphere than what we see today. Finally, there's the Mars Reconnaissance Orbiter, another NASA mission. It has detected features on the Martian surface that look like they were carved by flowing water. This suggests that Mars once had a thicker atmosphere that could have supported liquid water on the surface. These pieces of evidence paint a picture of a drastically changing Mars, but what does this mean for the future? Let's explore that in the next scene. With Mars's past becoming clearer, we can start to look towards its future. As we venture further into the cosmos, our sights are set on the red planet. Yet, the thin atmosphere of Mars presents a significant challenge for potential manned missions and colonization efforts. Mars's atmosphere is roughly 100 times thinner than Earth's. This thin atmosphere means Mars is exposed to more solar radiation, making it inhospitable for life as we know it. It's like being at an altitude of about 25 miles on Earth, where the air is too thin to breathe and the pressure too low to keep liquid water from boiling away. For any manned mission, the thin atmosphere of Mars poses a twofold challenge. First, landing on Mars is perilous. Without a thick atmosphere to slow down a spacecraft, a safe landing becomes a Herculean task. Second, the thin atmosphere offers little protection for astronauts against harmful solar and cosmic radiation. Now, let's address the elephant in the room. Colonization. The thin atmosphere presents an even greater challenge for future colonizers. Without a breathable atmosphere and protection from radiation, any future Martian colony would need to be self-sustaining and shielded. It's not just about getting there, it's about surviving there. Despite these challenges, our fascination with Mars is unwavering. We continue to push the boundaries of our understanding and capabilities. Scientists and engineers are working tirelessly to develop new technologies and strategies to overcome these obstacles. The goal? To make Mars a second home for humanity. In this endeavor, Mars's thin atmosphere, once seen as a hurdle, could become an opportunity. The carbon dioxide-rich air could potentially be harnessed to produce fuel, aiding both in the journey to Mars and the establishment of a self-sustaining colony. The red planet continues to captivate us with its mysteries. As we continue to explore, who knows what new discoveries await us? One of the biggest questions surrounding Mars is whether it could have once harbored life. This intriguing question has been at the heart of Mars research for decades, and it's one that continues to spur on scientists and space enthusiasts alike. Now let's consider the early conditions on Mars. Picture a time when the red planet was more like our own, with a thick atmosphere and vast bodies of water. We know that on Earth, where there's water, there's often life. So, it's not an outlandish thought that Mars, in its prime, might have been a cradle for life as well. There's a multitude of ongoing research and missions that are devoted to investigating this possibility. For instance, NASA's Perseverance rover, which landed on Mars in early 2021, has a primary mission to seek signs of ancient life and collect samples of rock and regolith, broken rock and soil, for possible return to Earth. Simultaneously, the European Space Agency's ExoMars rover, slated for a 2024 launch, will drill deeper into the Martian surface than any previous mission. The goal? To hunt for evidence of ancient life preserved underground, where it would be protected from the harsh conditions on the Martian surface. We must remember, though, that finding signs of past life isn't the sole aim of these missions. They also provide invaluable insights into Mars's past climate and geology. This knowledge is crucial for understanding the history of our own planet, and how life could potentially arise on other worlds. Yet, the search for life on Mars is not just about the past, it's also about the future. As we continue to explore Mars and understand its potential for sustaining life, we edge closer to the possibility of humans one day calling Mars home. Whether or not we find signs of past life, the journey of understanding Mars's atmosphere is a fascinating story of planetary evolution. And who knows? Perhaps we are not as alone in the universe as we once thought. So, what really happened to Mars's atmosphere? In the cosmic dance of planets, Mars has always stood out, a tantalizing mystery with its red hue and the secrets it holds. As we've journeyed through this exploration, we've discovered that the early Mars was quite a different world with a thicker atmosphere and possibly even liquid water. But then, something changed. The Martian atmosphere began to thin, slowly transforming Mars into the barren and desolate landscape we see today. But why did this happen? The evidence points to solar winds, those streams of charged particles flowing from the sun, which over time stripped away Mars's atmosphere, eroding its capacity to support life as we know it. These findings, though, are not just the end of a story, but rather, the beginning of many more. They pave the way for further exploration, for delving deeper into the mysteries of Mars, and perhaps even beyond. The future of Mars is an exciting frontier. With our evolving technology and insatiable curiosity, who knows what we might uncover next? Could there be microbial life lurking beneath the Martian surface, waiting to be discovered? Or perhaps the clues to terraforming Mars, transforming it into a second home for humanity, are hidden in its past? The potential for life on Mars, once considered the stuff of science fiction, is now a scientific question we're inching closer to answering. Each new discovery, each piece of evidence brings us closer to understanding not just Mars, but the broader universe and our place within it. While we may not have all the answers, the exploration of Mars's atmosphere offers us a unique window into the past and future of not just Mars, but potentially other planets as well. Our journey into the cosmic unknown continues, and Mars, with its mysteries and its past, beckons us forward, inviting us to seek, to explore, and to discover. Thanks for watching. Please remember to subscribe to Time Pilgrimage and smash that notification bell for more content.